It has to do with my family. Basically, my grandfather and his partner started a business almost 100 years ago. And that business is still existing, so we are very traditional. Agriculture started in 1928. So in 4 years, we will be celebrating our century. And I had an agreement, because this is a family business, although it has been growing quite a lot. So I had an agreement with my father. I told him, don't tell me anything about glass until I am 30. I want to do my life, and then maybe I joined the company. But then at the age of 30, I just learned about glass. I got really enthusiastic about it. So I joined the company, and that was already, let's say, 24 years ago. Well, basically, glass is demanded. So it's a material with unique capabilities. And curved glass offers the opportunity to have it in a way that you're not having it when it's flat. So we can adapt to geometry. And so basically what we are doing is we're working with one of the capacities of this extraordinary material. Our process, well, basically what we need to curve glass, it's ovens. So we have around 20 ovens. This is what makes us a little bit special. And we keep developing ovens for projects. So we try to be there at the peak of the industry, of the curved glass industry. It's what Nordstrom, these are IG units, so double glazed units. It's a laminated glass outside, laminated glass inside. And it was one of the first projects where we had a frit on surface number 1. Okay? And the geometry of the glass is quite unique. It's a wavy. I don't know if you see the facade, it's very wavy. And this frit on surface number 1 is eliminating part of the reflection of the glass, which is something that James Carpenter wanted for this facade. And it also captures the light. So it's a glass that depending on how you project light onto the glass, it keeps the light and it changes color at night, for example. So during the day it has a feature, and during the night it has a different feature, and both are quite unique, apart from the geometry. One other thing that the geometry is helping, but not so much in this project, is that the glass becomes very, very stiff. So it can work very well against wind loads. So we start with flat glass, always. We cut it. So we get sheets. The standard sheet in Europe is 6 meters by 3.21. And although we can get twice this size, so 12 meters or even 18 meters. But normally what we get is 6 meters, and we cut it. We work the edge to eliminate all the imperfections, all the flaws, to have the perfect size. And then next step is curving. And then depending on what we need, what kind of heat treatment we have to apply, if it's going to be an annealed glass or if it's going to be heat strengthened or a tempered glass, we use two different curving technologies. When we are doing annealed glass, we have to create a mold. Then we put the glass on top of the mold. If the glass is laminated, then we put the two panels, the two lights together on top of the mold, and then we curve that. We separate the two glass units from the mold, from the oven. This can take, I don't know, the curving time could be 6 hours, depending on the thickness, maybe 4 hours or 8 hours. If the glass is very thick, it takes longer. Then once the glass is curved, we can laminate it, and after lamination, we can assemble an IG unit. All right. If the glass is tempered or heat strengthened, we have to curve panel by panel, which means that we have to we put the glass inside of an oven. The oven is the same kind of oven for flat glass, but then at some point when the glass is hot enough, it comes out of the oven, and then it goes into the quenching section where the glass gets the shape of an automated mold that creates a shape in 1-2 seconds. The glass gets the shape that's needed, and then we do this process with one glass, then we do the same process with the following glass, with the same glass that will be together with this one if it's laminated, and then the third, the fourth, imagining that we are having an IG unit of laminated glass outside and the laminated glass inside. We would be curving 4 lights and then assembling 2 and 2, and finally doing the IG unit. Installing curved glass is a little bit tricky. It's more tricky than flat glass. You need special equipment like power caps to hold the glass. Also, a flat glass is very stable. Curved glass, you have to calculate how the glass will, once you pick it up, how it will behave. And also, when you incline it, you have to consider that it's 3-dimensional. So when you incline a flat glass, it's very easy. You can just insert it in a U-channel and then bring it down or bring it up and install it very easily. A curved thing, it's not so easy. And if imagine that there is a double curvature or an S shape, it's tricky to install. But we don't install glass, so we don't do that part. We just manufacture and ship. So one thing in our case, what's a little bit more difficult, apart from manufacturing, is creating, because sometimes what you produce is something that is not very stable. So it's not only producing the glass, but also producing the stillage that will go with that glass and will be shipped to the other side of the world. Yeah, I said that we are almost 100 years old, which is true, and it's also true that we learn every day. All right, because as you do things, you get new challenges every day. And once you achieve a milestone, there is another milestone that you have to achieve. So it's a never-ending story, And the material changes. In the past, it was only glass. Today, the glass can have a lot of things. There can be coatings, and many different coatings, and each coating can have a reaction inside of the oven, for example. And there are coatings that resist very well. There are coatings that maybe vanish at certain temperatures. Then you have to apply a frit. Sometimes you cannot apply a frit on a coating. You have to apply the frit on a different part of the glass, and then maybe you need another glass. So there are many different challenges, and sometimes there are moments that things are not that easy, or they don't go as expected. For example, one thing that when we have to price a project, there is one of the lines in the cost sheet that we do. It has to do with uncertainty, and it will be on one side we have what we call the technical wastage. That is, for example, from a 6x3 glass sheet, and you have to cut a 5x2 glass, there will be wastage. So that's the technical wastage. There is no way you can escape from that. But there is one other thing which is important to take into account, and this is how many times you will have to do, or how many units you will have to do 100 good units. And depending on the project, imagine a project with very difficult glass, sometimes you have to do 5 units to have 1 unit. If it would be something very special, all right? Imagine a very complex shape. And sometimes it's the first try, it's what you have, but sometimes you need to get like an approximation. So this is what is difficult. But I think at the end, what's good about experience is that you are very good at calculating what can go wrong. Sometimes you make a mistake in your favor, and you think maybe we will have to try twice or 3 times, and the first time the glass was okay. I remember we did a glass slide for a show in Düsseldorf for Glasstec, and there was a glass ladder to climb, and then a glass slide, a glass tube, and I thought we almost didn't have time to do it, and I thought, wow, we will try maybe 3-4 times and we will not achieve it, and we will have to change. And the first time it came out perfect. So that was a very good surprise. But we could, maybe it was the first time that we were doing such a thing. and it could have been an absolute disaster, and then we would need to find a different solution. But I think big disasters we never had, or at least, yeah, the maximum what we've done is we have calculated wrong the risk. That's the only thing.